All right, I don't really have a great title for this. This is like more integrals. And I will go ahead and tell you, there's two types of patterns we're gonna do today. Neither one of them is super likely to come up. However, they are written up there in those standards, so we're gonna cover them. I cover everything that's up there just to make sure that we've done everything. But if these kind of bother you, it's not like a super heavy topic, like something that's super likely to come up. Again, I don't really have a lot to say. We're gonna just do problems. There's two different like kind of patterns, if you will. We'll do like a few problems of each of them. And they both involve remembering something from pre-calculus. So we'll see how that goes. I have faith in you. I taught a lot of you pre-calculus, so I think it should be okay. And if not, I'm gonna explain the whole thing. So if you don't remember it, it's like totally fine. But yeah, it was two years ago, so you're kind of at a handicap.
No.
All right, so you can't just go through and divide everything by x, because it's not just an x, it's x minus 1. So in order to do that division, it is what we call a synthetic division. It's the thing with the number in the little box. Now you can get really good at these, and usually people start churning them out like little correct answer machines. What number goes in the little box off to the side? 1. It's whatever makes that 0. We're just going to do this as like a margin problem. This is like off to the side. And then check your countdown. Is it in order? Yep, 3, 2, 1, 0. You're going to thief all the coefficients from that. So 1, -3, 5, -3. And what I always say to joke around to try and get people to laugh about it and remember is people start trying to do the problem when there's nothing written there. And I'm like, what are you doing? You can't start until you bring down the first number.
Oh.
And then it is multiply, add, multiply, add, multiply, add, multiply, add until you get to the end. So if you can multiply and add, which you all can, you're going to be just fine. Ready? 1 times 1 is 1. This is very difficult, I know. And then add the column -2. And then you just keep doing it again. It's a process. 1 times -2 is -2. Add the column, you get 3. 1 times 3 is 3. Add the column. Now, for the first one, I made the remainder 0 to make it a little bit of a simpler problem. But do you see what we got there?
Yes.
Okay. So we can replace this with what we got, and it's going to be a much simpler thing. I'm just going to go fishing. I'm going to throw the question out there and see what I end up with. Do you remember how to write it? Like when you get these numbers, like how you put your... It's 1 power less, good, because you've divided out. So it'll be 1x to the 2, good, x squared, and then minus 2x plus 3 dx. You did that last year in pre-calc just without an integral symbol around it. That's like, you did all that last year. Now we're going to do the antiderivative. And it's a really simple one. You can just do it term by term. You don't even need a u substitution or any of that other stuff. Antiderivative of x squared. All right, 1/3 x cubed minus antiderivative of 2x x squared plus 3x plus c. And that's your answer. So that's really all there is to it. I'm just going to do a couple more of them. I'm going to show you what happens when you do get a remainder. So let's do one that does have just one extra term added on there is all that it ends up being. It's not like it's any harder, really.
It's not the end of the...
No. The problem gets a little larger. It's not like any more difficult. The hardest part always is figuring out which method to use when you have so many methods. Do you know what I mean? Do I need a u substitution? Is it one of the inverse trig patterns? Can I just do the problem? These ones, you can't just write an answer. Like you can't just work that backwards. And you can't divide everything by x because it's not just an x, it's an x plus 3. So that's how you can kind of identify like, oh, I need to do a synthetic division. So what number would go in the little box off to the side? Right, good, -3. Good. This is going very, very well. I didn't have to pull teeth with it at all. You guys remembered how to do this. All right, is your countdown in order?
Yes. Oh, but it skips one.
It skips x to the first. So you are missing. Do you remember what you put if something's missing? 0. Good. Okay, so it'll go 2, 4, 0, -5. Bring down the first number, and then it's multiply, add, multiply, add. Not really gonna say anything here. You guys know how to multiply and add. Let's just all do that and make sure we get the same thing, okay? And if you check the remainder and the remainder is the same, then, you know, probably did the rest of it, right? Did you get -23 as a remainder? Okay. So when we go to put that back in the problem, because that's the point, that's what we're doing. You start with 1 power less. So it's gonna be 2, what? Good, x squared, and then what? I got -2. -2x. I know, there's numbers everywhere, right? -2x plus 6. Now, the way you tack on the remainder, we have -23 over the x plus 3. What you're basically saying is we were not able to divide that part out, so it just stays. So when we go to do the antiderivative, you just have one extra term tacked on to the end. Again, it doesn't make the problem harder, there's just one extra term. No, a quotient rule is for a derivative and we're doing antiderivatives. No, I was waiting for someone to ask that, honestly. You were all thinking it. A quotient rule is for derivatives. We're doing an antiderivative, so that's. All right, so antiderivative for 2x squared. Yep, 2/3 x cubed, good, minus, that would just be x squared plus 6x. Now the last part. Technically, it would be a u substitution, but I just coach everyone to do it without writing all of that. You would let u equal x plus 3. But what's the derivative of x plus 3? 1. So you don't need to actually write out a substitution. It's going to be -23 ln x plus 3. If it was just an x, your antiderivative of 1 over x is ln of x. There's just a 3 in there. And then what do I need at the end? Because I didn't write it yet. Plus c. Good. And then that's your answer. So again, I'm going to say it again to make sure you understand how I did that. The antiderivative of 1 over x is ln of x. It's just it was an x plus 3 is all that is. I don't want you to have to write out u equals and do all this nonsense just for something simple like that. And they'll always end up simple. All right, and then I'm going to do one more of these. I'm going to show you what happens if you have boundaries. And this is how they do them on Delta Math, and they make you simplify the LNs all the way down. But it's not, remember that other section where they made that happen? These ones aren't as bad as that. They're a little bit better. But I am going to simplify it the whole way down, just as a heads up. All right, so do you notice you need a synthetic division? Like you can't divide everything by x because it's an x minus 4. All right, so we've established we need synthetic division. What number goes in the little box? 4 is our countdown in order. Yes, you get 4, -21, 23. And again, everybody just go ahead and do that and we'll make sure we all got the same thing. I don't want to talk through multiplying and add because this is going to put you all to sleep. Did you get 4, -5, 3? Oh, question, go ahead. Or no, okay.
I was resting my head on my head.
Oh, okay, gotcha. I just didn't want to ignore you if that was a question. Now, you don't have to change the boundaries. That's only for a u substitution because you're changing from x to u values. So you can leave them the same and you're going to go down a degree. So it'll be 4x minus 5. And then you tack the 3 on at the end. It's 3 over x minus 4. And I should have brought this up in the first one, but did you notice how in all 3 of these, I kept the integral and the dx on that step? Like you only drop that once you do the antiderivative, right? So now we're going to do the antiderivative. So antiderivative for 4x. Good, 2x squared minus 5x. And then plus, what would this one be? All right, you guys got it. Perfect. Don't put plus c Instead, it's such that 0 to 2, and we're gonna do upper boundary minus lower boundary. And again, I'm gonna simplify it the whole way down because that's how Delta Math does it. And also it's just, you know, good practice for you. So upper minus lower, leave yourself plenty of space. Let's plug in 2. 2 squared, 4, double that, 8, perfect. Minus 10, good, plus, now look, here's where you get to drop the absolute value because it's going to be an actual number. 2 minus 4 is -2, but the absolute value of -2 is 2. So it's 3 ln of 2. Good job, you guys followed me there. And then 0. Well, if you plug in 0 to both of these, like that's just, like this whole thing is going to be 0 plus 3 ln. Now 0 minus 4 is -4, but the absolute value of -4 is 4. All right, we're going to keep on going. 8 minus 10, -2, plus, now you are allowed to take the coefficient and put it back as a power. So it's 2 cubed, which is not 6. Please don't say 8. ln of 8. 2 cubed, 2 times 2 times 2. Minus, and we're going to do the same thing with this one. So you'd have to do 4 cubed, which is 64. Good, thank you. And then the last step is -2 is just going to be there. Whenever you subtract your logarithms, you divide what's inside of them. Subtraction means you divide. And it'll always be subtraction because you're doing upper minus lower. So it will be subtraction. So it would be 8/64, which reduces to 1/8. Good. And so that is how you would have to type it into Delta Math. And if you get stuck on that part, come up, I'll help you through it. Okay, but 2 cubed was 8, 4 cubed is 64. This means division. 8/64 reduces to 1/8. Okay. Okay, so here we're gonna do our, oh, whoops, that's supposed to be a 4. I'm gonna have to fix that because that's gonna bother me. We're doing the other pattern that we need to do here.
So are we gonna see this pattern or more like the last, the other side?
I would say these are both equally unlikely. But I've seen like one, you know, they might throw you one on the multiple choice and and again, I cover everything. Even if something seems really obscure, I'm still gonna cover it because it's fair game, you know, so. So do you remember those inverse trig patterns we did last time?
Oh, yeah.
You remember those?
Yeah.
Okay,
Yeah.
how I said there couldn't be an X in the numerator?
Yeah.
As a heads up, you know, spoiler alert, it's gonna turn out to be one of those. Can I show you real quick why a regular old U substitution won't work? Here, don't write this down, I'll just do it off to the side. If you were like, hey, let me let U equal that denominator. Remember how I said that's like your Hail Mary? Like, hey, just let U equal the denominator. Well, what would DU come out to be? Yeah, well, that has to be in the problem somewhere, is it? No, so that won't work. Like, it just won't work. You got to try something else. So what we're gonna do in this one, what did you say?
Don't listen to him. No, I think you should repeat yourself.
Check your attitude. All right, what you're gonna need to do is complete the square, which you did in pre-calc as well. And in fact, I think you do that in algebra 2 as well. All right, so copy down the first 2 terms. I'm gonna again just see what I get. Do you remember how to complete the square, like what you're gonna add on there?
Sort of do. Add 30.
We're gonna add 25. How, and then what I always say is give that a hug. Think backwards though. How did you get 25? Yeah, you divide by 2 and square. 10 divided by 2 is 5, 5 squared is 25. Now, believe it or not, and you're gonna have to extend this, you're not actually allowed to just go around changing the problem. You can't just change a 34 to a 25. I'm sorry to tell you. So what are you gonna have to add on at the end to turn it back into a 34? 9. And then you're a DX. So the whole point of doing that is that you can write it as something squared plus 9. And what goes in the blank is either X plus a number or X minus a number. Good, X minus 5. I call them a twin. If you were with me, these are the things I call a twin. Do you guys remember that? All right. So now, is it arcsine, arctangent, or arcsecant? Do you see how there's not a square root? It's gonna end up being arctangent. A is a number. What do you think A is gonna be? 3, good. U is that x minus 5. And what's the derivative of x minus 5? You have just 1 dx. So there is not an adjustment, and you can just write the answer. Did arctangent have that little fraction out front or not? Which is the one that didn't?
It was not.
It's not good. Well remembered. Oh my gosh, I love you guys listen to me and remember things. It's fantastic. So out front, you're gonna put 1/3 arctangent of what? U over, good. So x minus 5/3 plus c. And we're just gonna try that a couple more times.
That one got, that's kind of. much.
Well, we're gonna do it again. We're gonna do it again, all right? And what I feel is the hardest part of the problem, to be really honest, is just figuring out what method to use. So the way I look at these ones is, well, there's not an x in the numerator, so a u substitution won't work, so it's gotta be something else. It's gotta be one of those other patterns. And if it doesn't look like an arc pattern right away, then you have to rearrange it so it does, which is where complete the square comes in. So it's like, you know, kind of how I think through it. So we're gonna do x squared plus 6x, and then what would you need to add on? Not good. And then 3 squared is 9.
Okay, I think I'm gonna have to make this.
Now, you can't just change a 58 to a 9. It has, you have to maintain the integrity of the problem, is how I always say it. So, plus 49. And do you guys notice how it's gonna be a perfect square? Like,
Sorry, that, what? How is it?
Did it always work out like that?
yes.
Oh,
Because otherwise, instead of your A value being something nice, like this one will be 7, it would be square root of a number. And I've never seen that. They'll be perfect squares. All right, so this will be 1 over something squared plus 49. What's gonna go in that blank? Good. You guys are, it's coming back to us. We're remembering. So A is 7. U is x plus 3. And the derivative of that is just 1 dx. There's not an adjustment there. And again, typically there isn't. If it's one like this, it's not going to be complicated. So what's our answer? We can just go write the answer. 1/7, good. Arctangent,
x plus 3 over 7.
x plus 3/7 plus c. We're going to do one more.
Are they all gonna be arctangent?
No, I'm so glad you asked that.
Guess what? Here comes the sign.
There won't be an arcsecant though. There can't, why can't there be an arcsecant like for this? There's that little doodad that's out front, and that like just the pattern won't work, so there won't be one of those. But you can do arcsine. So let me show you how that works out. So if you look at that and you go, yeah, that's gonna be a nope from me. You're a normal person. Okay, but then you should be like, okay, well, there's a square root. Like, I hope that if you came across something like this in a multiple choice, which is where you'd see it, I hope you would go, well, there's a square root and there's no variable in the numerator, so it's probably arcsine. And if it's multiple choice, there's probably only gonna be one choice that says arcsine. So like you could get the answer, right? But let's go ahead and actually work it out. Now, for this one, do you see how there's a negative in front of the x squared? We're gonna divide out a negative, but only from the first 2 terms. If you were with me, you remember me saying that over and over again. Like if there's something there, you're gonna divide it, but only from the first 2 terms. What that's gonna do is just make these both positive. Do you see that there? Okay, so it'll be x squared plus 4x. And then this is where we complete the square. It'll actually just be 4. And that's because 2 plus 2 is 4 and 2 squared is 4. Now hold on. It's actually a negative 4. So you have to turn a negative 4 back into a positive 12. So plus 16. Negative 4 plus 16 gives you 12. is what happens there. If you were like, what just happened? Hold on, can I explain it? Stick with me.
Okay.
If you were to, here, look, humor me. I'll do a sticky note thing off to the side. If you were to distribute this negative sign through there, humor me, don't stop listening. You would get negative x squared minus 4x minus 4 plus 16. And if you put those together, there, do you see how it comes out to?
Yeah.
What we started with? We just did it backwards.
Yeah.
Okay, you can always work backwards.
Okay.
Right, so now it's gonna be 1 over gigantic square root. Do you see how this is negative out front? I'm gonna write it the other way around. So I'm gonna write 16 minus something squared so that it'll look like our pattern. And it'll be what in those parentheses? X plus 2. Good. So what's A?
No.
4. Good. U is x plus 2, du is just dx. And typically they turn out that. I don't think I've seen one that isn't like that, all right? It's arc sine, it's got a square root, but it doesn't have that extra doodad out front. Now, did arc sine have that fraction out front? No, so don't put it. You're just gonna put arc sine x plus 2 over 4 plus c. And I'm gonna say this again, so it ends up on the recording. The ones in your delta math turn out like this, and you have to reduce the LNs. So if you get stuck on reducing the LN stuff, come up here and I'll help you with it, okay?
Alright, so